Hi everyone, I am Jyotsnarani Tripathy from Department of IT as working as assistant professor in VNR VJIT Hyderabad. Today I am continuing my second video with that same Apriori algorithm with another example. So before going to that second example, first I quickly just finish that first example. So then we go to that next example. So that previous example, what I show you in that previous example, that is supermarket. There are 9 transactions there. Within that T100 to T900, there are 9 transactions and minimum support given to 2 and minimum confidence given to 60. So the question that time was find all frequent item set and generate a strong association rule and identify the most frequent pair. So in that day, I discussed about how we calculate the support and confidence and what are the formula behind that. So quickly, I just briefly said that the support count, how we count it means whatever be the item sets are there present. Suppose item T100 within that I1, I2, I5 are present means we count here I1 as 1 and I2 here 1 and I5 is 1. Next in T200, I2 is 1 and I4 is 1 here. Then next in 300, I2 means I2 we calculate as 2. Like this, we calculate all the frequency of that items. So how we calculate that support count? The support count here it is number is given. We count it as a number with the percentage means I1 how many times occurred. I1 divided by the total number of transactions there, and into 100 we count the percentage also, and from that also we count how many support count also. Suppose here the minimum support is given to that 2 by 9 into 100, that percentage also we calculate. So that is the that question I discussed already. So what is the solution? We find out that here the frequency of first iteration L1, L2 and L3, and we found that L4 there is not any frequent 4 item sets because it is a combination of 4. The 4 item sets are not so frequent. So in L1 1 items we count I1, I2, I3, I4 and I5 all are there present. Why? Because all are more than 2s are the frequency is present. And in L2 the frequent 2 item sets we find out that combination of I1, I2 and I1, I3 and I1, I5, I2, I3 and I2, I4 and I2, I5 all are the more than the support count which is 2 is here and there. So in L3 here 3 item combinations we found out that I1, I2, I3 and I1, I2, I5 which have the support count is more than 2. So we consider up to L3 and we discard the L4. Why? Because its support count of 4 item sets combination which is less than the support 2. So whenever we are taking here frequent item set is 3 item sets. So the strong we are find out here means in that we calculate which is strong. So why? Because we are calculating the L2 also, but the L3 is the maximum limit we are going. So we are find out the strong association rule from there only. So how you calculate I5 to I1, I2, then I1 I5 to I2, then I2 I5 to I1. These the threes are only we are getting in that time. It's strong, and rest the combinations are weak only. So we consider as in the formula is written in the right side. There all the formulas is there. So they are showing that. Means confidence x here to y, we how we calculate it, support x union y and divided by support x into 100, that we are calculating the formula. And next minimum confidence is 60%, and the strong rule we are getting here, that is I5 to I1, I2 and I1, I5 to I2 and I2, I5 to I1. So this in that previous class we already finished that one. So the answer our is look like this. These are all the frequent item sets which having more than two support we find out, and then the strong association rule is I1 to I5 to I1 I2, then I1 I5 to I2, and I2 I5 to I1. So here in that last we are writing most frequently purchased pair, which is I1 and I2, I1 and I3, and I2 and I3. Why? Because it is more than 44.44% support, which is 4. If we count it as it is 4, and from these frequent item sets, there are more combinations. Look here, it is in L2, it is more combinations are there. I1 I2, I1 I3, I1 I5, I2 I3, I2 I4, I2 I5. But we are taking here among these which most frequently purchased, these threes we are taking. Why? Because it is more than 44.44%, which is 4 among 5 means that items. Here it is only, among 9 transactions, in the 4 transactions these 3 items are there present. So we are taking I1 and I2, I1 and I3, and I2 and I3. So next we will discuss about another example, which having given in the question the minimum support is 40% and that minimum confidence is 70%. So here we are just seeing the example of a supermarket purchasing pattern analysis, where bread, milk, butter, and how combinedly that transactions we are here means giving in that examples. And then next, how from that we find out our minimum support count and minimum confidence. Okay, so here given 5 transactions. This is one small example which is given here 5 transactions where bread, milk, bread, butter, bread, milk, butter, and here milk, butter, and bread, milk. There are 5 transactions. So in transaction 1, bread and milk only, transaction 2, bread and butter only, and transaction 3, bread, milk, and butter, and transaction 4, milk and butter, and T5 equal to bread and milk. So here within that 5 transactions, so we have to find out the minimum support. So in the previous example we directly write that the minimum support count, and here I means write both the things. Minimum support is given here 40%. From the minimum support, how we count the minimum count? 5, which is the total number of transaction, into 40% equal to 2. That means if from bread we are count here in that total 5 number of transaction, 2 breads are there. That means here it can support that minimum support. Next, like this we have here calculate for these all items, bread, milk, and butter. All the items we have to calculate it. Then next, what is our task here? We have to find frequent item set, generate strong rules, and find most frequent pair. So in the previous, those who are more than 40%, we are taking our frequent item sets, they are around 22.2%, which is 2 there. But here means there we have to write the strong more frequent patterns which are more than 4 are there present. We are taking these are the most frequent, which is our third question answer. So here also according to our this question, how we solve it? Next, look here, what are the, whenever we are using all these algorithms, so we have to here find out what is the formula first, and what are the formulas are there, and what we should do in that formula. So in the support, you know that how you count the support. Support x, suppose x is the item, then count x, whatever the count is given for the x, divided by total transaction into 100. So confidence for that formula is confidence x tends to y equal to support x union y divided by support x into 100. So I already said in the previous video that confidence of x tends to y is same, means what is the result of confidence y tends to x. Here the support of x union y same as y union x. So we are writing support of x union y divided by support of y into 100. So like that we have to calculate our confidence there. So here confidence is given which is more than 70%, that is it is a strong rule. Okay, so the minimum count equal to 5 into 40% equal to 2, which we already counted. So next, what is the principle here? If an item set is infrequent, its larger superset, we are here pruned that one also. So this is the principle of that a priori algorithm. So what should we do next? This is our data sets, and we have to calculate from that data sets how many breads are there, how many milks are there, how many butters are there. Here this is the step 1 where we find out the C1 and L1. So here we count it, and we find out that count equal to 4. So our support is here 80%, which is frequent, and count of milk equal to 4, which is 80%, which is also frequent. Count of butter equal to 3, which is 60%, which is also frequent. So in the L1 we find out that bread, milk, butter, which all have count here equal to 4, which is out of 5 into 100, we are getting here it is 80%. So what is the result here? All in the right side I write the result that all individual items satisfy the 40% minimum support. So whenever we find out it can achieve the 40% minimum support, then only we can know that if it is frequent or not, and we take these counts only. So next, for L2, what we are doing? We are taking here 2 item sets. So previous for L1, we are taking here one item. Here we are combining it. So what is the combination? Bread, milk, bread, butter, milk, butter. Okay, so we count that, and the count is here 3. For bread, milk, if we once again go back, bread, milk, how many counts are there in the main data set? Look, here T1 bread, milk is there. T3 bread milk is there, T5 bread milk is there. So how many is? Totals are 3. So next, bread butter, how many is there? T2 bread butter is there, T3 bread butter is there. Okay. So next combination, what is the combination is? Milk butter. So milk butter is how many is? Go back to once again, milk butter is in that T3 also, in that T4 also. So how many times? It's also 2 times. So like this we have to write here, bread milk is 3 combinations, bread butter is 2 combinations, and milk butter is here 2 combinations. So once again we have to calculate. Whenever it is 3 by 5, it equal to 60%, which is frequent. Whenever it is 2 equal to 40%, which is frequent. And here all are above that 40%, which is frequent. So all 3 here pairs meet the minimum count of 2. Why? Because our minimum count, either we are taking 2 or we are taking here 40%. So 2 is the minimum count. So all the 3 we are taking here. Then next, what should we do? We are here creating for the 3. So step 3 is we are counting for the combination of 3, bread, milk, butter. Okay. So whenever we combine it, and we are getting that it is only one value. So 1 divided by 5 into 100 equal to 20%. So just look at students, these all counting or combinations, it's so easy to means count that thing. Why? Because it is only find out the percentage. You have to remember the support and confidence formula. According to the formula, you just put that values and you are getting your answer, and you compare that. In the question it is given that much, and if it is more than that or equal to that, you are taking that one, and if it is not more than, you discard that thing. This is the pruning operation. So it's so easy to solve that. How that pruning operation is here happened? Here we are getting the support in that candidate 3, we pruned it and we are getting the support count which is less than 2. So what we are not taking this. So no frequent 3 item sets exist. So therefore our here L2 is the highest frequent labels. So in the previous example we are taking L3 as the highest and L4 we stop there our algorithm, but here we are taking a less data sets. There it was coming L1 to L2, L2 to L3, and next we stop here at L3. So we are not considering it L3 here. So we are considering up to L2 there. So when we consider it, so how we write the confidence then? What is the strong association rule is next question. So look at this slide. So I will explain one by one how that strong association rule we have to generate. So if L3 is here blank, so we generate only up to L2. So in L2, what are the combinations are there? So bread to milk, milk to bread, bread to butter, butter to bread, milk to butter, butter to milk. What I already said in that confidence formula, go back to once again the L2. Okay, so in the L2, what we are find out here? Bread milk, bread butter, milk butter. So whenever we find out the confidence here, bread we are taking as X, milk we are taking as Y. So X tend to Y. So we find out that the confidence of X tends to Y and we are find out our confidence. Once again we are taking here milk as X and bread as Y. So that X and Y and the values are different. So bread butter like this, butter bread. Milk butter like this, buttermilk. So what should we do here? We are combining is bread milk, milk bread, bread butter, butter bread, milk butter and buttermilk. So how we calculate here? That 3 by 4, 3 is the bread and milk because it is union of X union Y. So support of X union Y divided by support of X. So here X is bread and Y is milk. So 3 by 4, 3 is the total combination X union Y which is bread and milk and divided by only bread. Okay, so here 3 by 4, once again we go back. Union if it is achieved or not. Look, bread and milk 3. Okay, the first value is 3. Only bread what is 4. Okay, so this in the C1 we are getting only bread what is the value 4 and the bread union milk what is the value 3. So here we calculate like this 3 by 4 into 100 which is 75%. Like this in the milk bread also we combined it and we know that X union Y equal to same Y union X. So 3 by 4 is the same but divided by 4 if it here it is a bread. Okay, in that previous it is milk but here fortunately bread is also the value of 4. So what we are doing? 3 by 4 into 100 which is 75% which is strong. Like this, we are calculating all these values, bread butter, butter bread, milk butter and buttermilk. So, which is 2 by 4 into 100, which is 50%, which is not strong because our minimum confidence is given 75%, 70%. You look at the right side, which is 70%, and all the top twos, they are 75 and 75. So, they all are achieved that one, which is strong. And below that, all the 50%, 66.67% all are less than 70%. So what we are getting that strong rules are here from bread to milk and milk to bread because this can achieve that 70% minimum confidence. So next, what is our answer here? So the frequent item sets are bread, milk, butter, bread milk, bread butter, milk butter. So these are the frequent item sets which having more than that supports there. But the strong association rule is bread to milk and milk to bread, which we here find out these two are the strong rules. Okay, so next most frequent patterns are here what? Bread and milk with 60% support appearing together 3 out of 5 transactions. So in the previous examples we are getting 3 combinations which are more than 4 values are there, means 44.4, which is there more, that in their data set it is more, and here in this data sets it is more with 60% support. So finally, once again we conclude that whatever that problems are given, so first we remember that formula, and according to the formula here we implement all the rules, and we are find out that what are the frequent item sets, and we prune that, and we are getting that next from L1 to L2, L2 to L3, and L3 if L4 it is support, otherwise we stop it, and whichever be the maximum L1, L2, L3, which is the maximum, we are getting the strong rule from that, and we are here giving that most frequent purchase pairs from that also. So that is all about the Apriori algorithm. Hope that you people are understood all these concepts. I given here first example, one example with 9 transactions. Here I given 5 transactions, another examples. I think that all of you clear in this Apriori algorithm. Thank you.